Let's start this lesson with a little warm-up. A warm-up about dependent or independent events. We're going to classify each set of events as independent or dependent and see how we do. Event A in number 1, drawing a 3 from a deck without replacing it. Event B, drawing another 3 from the same deck. Without replacing means we're taking the 3 out and it doesn't get put back in, so now there are less 3s to choose from, so these would be dependent events. Number 2, event A, tossing heads on a flip of a coin. B, tossing heads on a second flip of the same coin. Those are independent. The coin doesn't change. We pick it up and we try again. Number 3, running between 5 p.m. and 5:30 p.m. B, drinking water between 5:30 p.m. and 6 p.m. You could argue this both ways, but I know personally this would be dependent for me because I would be more likely to be drinking water after I'm running. Event A, drawing a blue marble and putting it back in a bag that contains 6 marbles and 4 red marbles, 6 blue marbles and 4 red marbles. Event B, drawing another blue marble from the same bag. We draw a blue marble, put it back. Once we put it back, we have the same number to choose from. Those would be independent. Let's read through this scenario and just think about it. Have you ever thought about the likelihood of an event happening? Take a look at this dilemma. Telly and Carrie were already hard at work when Ms. Kelly came into the bike shop on Thursday morning. It was 3 days before the big race, and there was still a lot of work to be done. "I can't believe it," Miss Kelly exclaimed as she came into the shop. "What?" both girls asked, alarmed. "There is a 4 to 5 chance that it is going to rain on Saturday. I just heard the weather report," Miss Kelly said, sighing. "Well, there's still a chance that it won't," Telly said, trying to cheer her up. Think of how that might be the same or different than the probability we've been working with. Our objective in 10.4b is to learn to calculate odds. And our essential question, how do I convert between probabilities and odds? We have odds in favor and odds against. The odds in favor of an event is the ratio of favorable outcomes to unfavorable outcomes. Favorable meaning what you're trying to figure out is going to happen, not necessarily favorable that it's exactly what you want to happen, but it's what you're looking for. The odds against an event is the ratio of unfavorable outcomes to favorable, so you just switch them around. Odds in favor would look like A to B, odds against would look like B to A. We write odds as a ratio, not as a fraction, because probability and odds are different, so we don't want to confuse them. Together, A plus B will equal the total number of outcomes, which is also different than probability, where we're finding our favorable outcomes out of the total. Now we're comparing favorable to not unfavorable. So in a club raffle, 1,000 tickets were sold and there were 25 winners. Estimate the odds in favor of winning this raffle. In favor means you want to win. So the number of favorable outcomes is 25 because there are 25 winners. The number of unfavorable outcomes would be 1,000 minus 25, which is 975. So the odds in favor of winning this raffle would look like this, 25 to 975, or 1 to 39. This means you have 1 chance of winning to every 39 chances of losing. This is different than probability. So we're just breaking it down to see how many ways can I win, how many ways will I lose. Same raffle, 1,000 tickets were sold and there were 25 winners. Estimate the odds against winning this raffle. The odds of winning in favor were 1 to 39, so for odds against, we would take that and reverse it. So 39 is the number of ways to lose compared to 1 way to win. Probability and odds are not the same thing, but they are related. Suppose you want to know the probability of rolling a 2 on a fair die. The odds of getting a 2 are 1 to 5. There is 1 way to get a 2 and there are 5 ways to not get a 2. But the probability of getting a 2 is 1 out of 6. The major difference is that in probability we're taking our outcomes out of a total, where in odds we're just comparing what we have and what we don't have, or what works and what doesn't work. So to calculate our probability, if we're looking at odds in favor of an event, we would put the odds in favor over the odds in favor and against added together. So in a club raffle, 1,000 tickets were sold and there were 25 winners. What is the probability of a ticket holder being a winner? So now we're looking at probability. There's 25 ways to win out of 1,000. That reduces to 1/40th. Our odds were 1 to 39. See how when you add these together, you get the 40? That shows how they're different. If the odds in favor of winning a CD player in a school raffle are 1 to 49, what is the probability of winning a CD player? So we're being asked for the probability, which would be a fraction, decimal percent. So because the odds were 1 to 49, that means there are 50 total outcomes. In favor would be 1 out of 50. If you haven't seen enough examples, make sure you ask questions and we can come up with some more easily to compare odds to probability, how they're different and how they work together.